All right, guys, so we're going over the review sheet today. So there are two parts to the review sheet. If y'all notice that, because if you haven't looked at it yet, that's fine. Because it had the review all the way up, then it had an answer key, then on the next page there was more to the review sheet. Because there was two keys. I don't remember off the top of my head, but there is two parts to it because I split it apart so that there is a good portion with I and not just a 2 or 3 questions. Because I think y'all actually wanted more with I. Powers, addition, subtraction, multiplication, division. So the first ones we'll look at, 1 through 12, factor the following polynomials. Is there one of those in particular that y'all want to look at? So we can look at number 2. 9r squared minus 36r minus 45. Whenever we factor, the first thing we look for is a what? Greatest common factor. And there is one here. It is 9. And we'll factor it out. We'll divide it out of each term. Because when we divide it out, we're left with r squared minus 4r minus 5. After we do that, we have 2 sets of parentheses with 3 spaces. Our next step was to look at the sign of the third term, and since the third term is negative, our signs are opposite. One is going to be positive, one is going to be negative. So that brings us all the way up to the factors of the first and third term. Well, the factors of r squared are r, and the factors of 5 are 1 and 5. Then we will check it just to make sure we got the correct factors. Well, r times negative 5 would be negative 5r. Positive 1 times r is plus r, which gives us negative 4r, which is exactly what we wanted. So that right there is our answer. Because number 1 would be handled the exact same way. We would factor the 7 out, 2 sets of parentheses. Moving on from there. We can look at number 3, 3h squared plus 11h plus 6. We're wanting to factor this here. So the first thing we do look for is the greatest common factor. So I'll have 2 sets of parentheses with 3 spaces. The next thing we look for is the sign. So we look at the sign of the third term. Since this one is positive, the signs are the same, and they match the sign of the middle term, which is, so they're both going to be positive. And once we get it set up like this here, we look at the factors of the first and third term. So we're looking at 3h squared and 6. Well, the factors of h squared are still going to be h and h. Whatever the variable is, we're going to have it in the first spot if it is in the first place. Since 3h squared was first, h and h would go in the first spots. Now, what are the factors of 3? 1 and 3, so we can just put really 3h and h. Even 1. Now, the factors of 6 are, which one do we want to use? We can try 2 and 3. If it doesn't work, we can change it. Because again, our last step is to check it. 3h times 3 is 2h. 2 times h is plus 2h, which gives us a positive 11h. Is that what we wanted? Now, if it ever gives us a middle term that's not what we're looking for, we can always change it. Either changing the numbers in the first spot, so the 3h and h, 2h and 3h, or the 2 and 3, we can flip it or change it to the other factors. Any other questions on these here? Questions on 5 or 6? Is there a greatest common factor between 3n squared, 5n, and negative 2? So we'll have our two sets of parentheses with 3 spaces. The next would be the signs. Since the 2 is negative, our signs are opposite. Then we'd be looking at the factors of the first and third term. Well, we'll have n and n because 3n squared, n and n would be a factor. Now, well, 3 is going to be 3 and 1. And the factors of 2 are 1 and 2. Last thing we'll need to do is check. So 3n times negative 2 would be negative 6n. 1 times n is plus n, which gives us negative 5n. Is that what we wanted? Yes. If we get the correct number but wrong sign, we can change the signs. Because when we do that, 3n times 2 is going to be plus 6n. Negative 1 times n will be negative n, which would give us a positive 5n, which we do want. So those would be the correct factors. Any other questions on 5 or 6? Questions on 7 or 8? Is there a greatest common factor with number 7? I would say negative 1. I would factor that negative out to make it a little bit easier to work with. Now when we look at the side of the third term, sign of the third term, since it's negative, our signs are opposite. Then we'll look at the factors of the first and third term. Well, we will have c and c, but our factors of 4 are 1 and 4 or 2 and 2. Which one do we want to try first? 2 and 2. And the factors of 5 are 1 and 5. And lastly, we can check this here. 2c times negative 5 would be negative 10c. 1 times 2c is plus 2c, which gives us negative 8c. Yes. Saying 4 and 1. Right, because 2c and 2c, even if we flip the 1 and 5 or the 2c and 2c, it really wouldn't change anything. So we'll look at this here. 4c times negative 5 is negative 20c. 1 times c is plus c, which is negative 19c. Is that what we wanted? Yes. So that there is the correct factors. And factoring out the negative 1 will make it a little bit easier to work with. Any questions on number 8? Okay. This one is one of our special ones. What did we call this here? The difference of perfect squares. Difference of perfect squares. Because when we look at this here, is 4n squared a perfect square? Is there something that multiplied by itself that gives us 4n squared? What times itself is 4? What times itself is n squared? N. So 2n times 2n is 4n squared. What times itself is 49? So we have two perfect squares and they're being subtracted, yes? So it is a difference of perfect squares. So the signs are automatically going to be opposite. And we said what times itself was 4n squared? 2n, 2n. 49 is. The difference of perfect squares formula really is a squared minus b squared is equal to a plus b times a minus b. And we could have worked it out the same way we do normally. And if we check it, do we have any middle term? Well, 2n times negative 7 is negative 14. N, 7 times 2n is plus, which is 0. We don't have a middle term. So 2n plus 7 times 2n minus 7. Questions on this here? Questions on 9 or 10? Is a squared a perfect square? Is 25b squared a perfect square? So we'd have plus and minus, and what would go in the first one? And b, and then a and. And number 9, if I remember, because that's 12. So I think this is 14x minus 12 times plus 12. 13. Yep. Yeah, it should be 14 because 169 is 13. Now what's interesting with this here, is there a greatest common factor between 14 and 12? 2. So I could factor it out of this here. Well, I can actually factor 2 out of both of these here, yes? Which would leave us with 7x minus 6 and 7x plus 6. So really we have 4 times 7x minus 6 times 7x. I'll have to fix that. So in the first set of parentheses, 14x minus 12, is there a greatest common factor of 2? Yes. So I have a 2 coming out there. The other set of parentheses, there's another greatest common factor of where you can bring them both out. And what's interesting is if there is a greatest common factor for the difference of perfect squares, it's going to be a perfect square. Because if the original equation was a difference of perfect squares, the greatest common factor that's going to come out should be a different or a perfect square as well. The only time it won't be is if the two numbers we have weren't perfect squares with it. Any other questions on this here? Questions on 11 or 12? These here will factor just like we did the first ones. They just turn out to be a perfect square trinomial. What we get in both will be the exact same. So 11 would be a minus 14 times a minus 14. Questions on 13 through 16? So, I mean, we can grab a calculator and say 64 minus 25 squared. I believe it should give you 3,471. That's it. Because, I mean, any one of these here, we just have two numbers, so we could plug it straight into the calculator and get an answer. Questions on this here? Questions on 17 through 23? Okay. So what are the directions for 17? So how could we solve this? Because what were the different ways we learned to solve quadratics? Graphing was the first one. The next one was, because we did it for 1 through 12, factoring. We also had the square root method, completing the square, or the quadratic formula. Because really, if you're using completing the square, number 18 would be, because we don't have a middle term. But for this here, if it says any method, could we graph it? I mean, if I graph it and it gives me two answers, am I done? Well, yeah. Because if we wanted to graph it, we can graph it. Now, we could try factoring. Two sets of parentheses with 3 spaces. Since the third term is positive, the signs are the same and they match the sign of the middle term, which is positive, plus, and plus. Then we look at the factors of the first and third term. Well, factors of x squared are just x and x. Factors of the third term are 1 and 2. And lastly, over to the side, we can check it. X times 2 is 1 times x is, which gives us a total of, is that what we wanted for the middle term? Okay. So this will factor. And since I have two things multiplied together equals 0, one of them must be 0. So we can say x plus 1 is equal to 0, or x plus 2 is equal to 0. Now to solve for the value of x, we would subtract 1 from both sides, telling us x is equal to -1. Here we would subtract 2 from both sides, telling us x is equal to -2. Could we have graphed this and gotten the same answers? As if it will give us whole number answers, graphing will also give us the answers. Any other questions on 17? Questions on 18? Yeah, we can do that one. Now this one here, again, if it says by any method, go on and graph it, see if it'll graph. Because if it's whole number answers, might as well. If we use the square root method, I would add 9 to both sides, which will tell me that x squared is equal to 9. And then we would square root both sides, which x is equal to what? Be careful with that there, the plus or minus. There's a few of the assignments I have graded from this hour and other hours where y'all are dropping that off and getting a answer. Because with any of these quadratics, when we solve it, how many answers do we get? 2, every single time. Now, even if the answer is -1 plus or minus I square root of 7 over 4, there's still 2 answers here. Because when we look at this here, really we're saying that one of the answers is -1 plus I squared of 7. And the other one is -1 minus I squared of 7. The plus or minus gives us 2. anytime we have these here in solving, we should have two answers. Now, they might not be unique because we could have x is equal to negative 11 and x is equal to negative 11. It could be the same answer, but we will have two. And if it does work out that the answer is the exact same, you can write it twice or write it once. I will take either. Questions on 19 or 20? We can do number 20. Now, what we do need is that this is equal to 0. So we can subtract 2x from both sides, which gives us 1/5 x squared minus 2x plus 6 is equal to 0. Now we can try graphing this here, and it will cross the x-axis at two places. It just won't be whole numbers. So from here, we could try, well, factoring won't work too well because it's not whole numbers, so there's a chance that it could factor, but most likely it won't. So we're left with really completing the square or quadratic formula. And in either case, this 1/5 is going to be a little bit of a bugger either way. So what we can do is I'm going to multiply the whole thing by 5. Because 5 times 1/5 is 1, so we have x squared. 5 times negative 2 is negative 10x, and 5 times 6 is plus, and 5 times 0 is 0. But we can scale an equation up or down by multiplying it by a number to make it a little bit easier to work with. Why don't we just use the quadratic formula? Negative b plus or minus square root of b squared minus 4ac all over 2a. So negative b, well, b is, well, negative 10 is just positive 10. Inside the square root, we'll have negative 10 squared minus 4 times 1 times 30. All over 2a, well, a is 1. 2 times 1 is 2. So Chloe, because I don't know if you watched the video from 3.6 yet. One of the things, because again, there's two things that I do all at once when I plug the numbers in. One of them is negative b. Well, we're just changing the sign from b, either positive, negative, negative, positive. I feel comfortable, if you feel comfortable also, that's fine, to go from saying, okay, b is negative 10. Well, negative b would just be 10. The denominator, 2a, well, whatever a is, we're multiplying it by 2. I will do those all at once because they're not that bad. If you need to go on and write them out, write them out. Now what we do next is what's inside the square root. We won't plug the square root in with it also, because we can plug in everything inside of here. And I believe is 10 squared minus 4 times 1 times 30. Would be negative 20. Now the calculator won't simplify negative 20. The yellow calculator won't, but we can bring the negative out as, which does leave us with the square root of, which it can do, which will tell us that it's 4, not 4, It would be 2 square root of 5 over 2. Because square root of 20 is 4 times 5. Square root of 4 is 2. And we can't take square root of 5, so it stays inside. Now, if the top two numbers, 10 and 2i, are not both divisible by 2, or whatever the denominator is, we'll leave it alone. But here, 10 and 2i are both divisible by 2. Well, 10 divided by 2 is? 2i divided by 2 is just I square root of 5. So here the answer is 5 plus or minus 5i square root of 5. And I believe that goes along with the graph because it did not cross the x-axis. We know that we will have imaginary solutions or complex solutions. Any other questions on this here? Yes. Um, yeah, because that works with any of these. And it's mainly coming from the fact that I have 1/5 x squared. Because 1/5 times 5 is 1. And we can do this with any type of problem or situation. So if we had, say, 1/2 x squared plus 1/3 x minus 4, I can multiply the whole thing by 6. The 6 times 1/2 would be 3. 6 times 1/3 would be 2. And I've eliminated all fractions. So we can use that scalar multiplication to eliminate fractions if it's going to make the equation easier. So here, since we had the 1/5, I just multiplied everything by 5 to get rid of the fraction. Now, if it worked out that it was graphable, we could have just done 1/5 x squared minus 2x plus 6, hit enter, and hey, those are the solutions. But because we had to work it out in the quadratic formula, if we'd have left it as 1/5, we would have had a fraction most likely in the denominator of the quadratic formula, which isn't terrible, but it's a little harder to work with. Any other questions on 19 or 20? Questions on 21 or 22? So 22, do we have a middle term? No, because we don't have an x to the first power. So that means we can get x squared by itself. We can use the square root method. If we don't have the middle term, we don't have x to the first power, I'll use the square root method. Get the variable, the x squared or the set of parentheses squared by itself. And once we do that, we can take the square root of both sides, which will tell me x is equal to plus or minus. Because the square root of 100 is 10, and the negative comes out as, all right. Questions on 21 or 22? Question on 23. Okay. Questions on 24 or 25? Huh? Almost. What do the instructions say? Solve each equation by completing the square. Now, I will say on these here, there will be several on the test that ask for a specific method to solve them. If you don't remember the square root method on the test, but know another way to do it the other way. okay? Because I do assign points for doing these by the completing the square method. But if for some reason you're spacing out, something's not working, you can't get it that way, go on and solve it another way. Because again, there are points for doing it. There's points for getting the correct answer, and there's points assigned towards using the correct method. Leaving it blank, you lose all points. Or even not finishing it, you lose all, or you don't get correct answers for solving it. But if you can solve it another way, go on and solve it so that you get the points for doing it, you get the points for the correct answer. You only lose a point or two for not doing it by the correct method. I'd rather you get the points for actually solving it, getting the right answer, than just leaving it blank or partway through. Now, for the square root method, is there one of those in particular y'all want to look at? Because we'll do one. 25. Now, since we're using the square root method, because most all the other methods, we wanted this thing equal to 0. Well, our second step in on the square root method is to get the variables on one side and the constant terms on the other, yes? Is it already set up like that? Well, yes. So there's no reason to move the 50 back over. We're just going to leave it over there. Our first main step was, is A equal to 1? If not, make it so. So here we would divide everything by 5. Because what that would leave us with is x squared plus 6x plus blank is equal to negative 10 plus blank. Because again, the reason we're doing this is we want to make a perfect square trinomial. So we moved the, well, the negative 50 was already on the other side. We got A equal to 1. Now we find the value of C. Well, C is equal to B over 2 squared. Well, the value of B is 6. Well, 6 divided by 2 would be 3. And 3 squared is 9. So the value of C that we want is 9. But yes, it is, we are going to have the 3. Because when we rewrite it as a set of parentheses squared, it would be x plus 3. Because we needed the 9 to know what to add to both sides. And it would be x plus 3, because x plus 3 squared is x squared plus 6x plus 9. Now on the other side, we'll have negative 10 plus 9, which is negative 1. Now at this point here, we would square root both sides, and the square root and square would cancel, leaving us with x plus 3 is equal to plus or minus I. Because the square root of negative 1 is, by definition, I. And last but not least, we would subtract 3 from both sides, which tells us x is equal to negative 3 plus or minus I. Any other questions on either one of these here? Because if you want to look at 24? Yeah, let's look at 24. 2x squared minus 12x minus 24. Was everybody finished with writing down 25? Yes? Okay. Well, the first step in the completing the square is A equal to 1? Well, no. So we need to make it so by dividing everything by 2. And what that would give us is x squared minus 6x minus 12 is equal to 0. Well, our next main step that we didn't have to do for 25 is we need the variables on one side and the constant terms on the other. So here, we're going to have to add 12 to both sides. And what that will leave us with is x squared minus 6x plus blank is equal to 12 plus blank. And we leave spaces because, again, we're going to find the value of c and plug it back in. Now, again, c is equal to b over 2 squared. Well, the value b in this case is negative 6. And well, negative 6 divided by 2 is? And negative 3 squared is positive 9. And once we get to this here, we're going to rewrite this as a set of parentheses squared, our x squared minus 6x plus 9. Inside, we're going to have x. And again, this is really coming from the number inside the parentheses, would be x minus 3 squared is equal to 21. Now our next step would be to square root both sides. Here the square root and square would cancel, leaving us with x minus 3 is equal to plus or minus. Can we take the square root of 21? Not and get whole numbers. There's no way to reduce it either, because the only factors of 21 are 1 and 21 or 3 and 7. And neither one of those would reduce. And last but not least, we do need to add 3 to both sides, which tells me x is equal to 3 plus or minus the square root of 21. Any questions on any of this here? (26) and 27, solve each equation by the quadratic formula. Which one do we want to look at? 27. Now, the quadratic formula, we need this thing equal to 0. So we need to get everything on the same side of the equal sign. Bless you. What I would do first is I would add 4x squared to both sides. And what this would give me is 4x squared minus 7x plus 6 is equal to 0. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So b is negative 7, so negative b would be positive 7. Plus or minus the square root of negative 7 squared minus 4 times 4 for a and 6 for c, all over 2a. Well, a is still 4, and 2 times 4 is 8. Now at this point here, I would just take what's inside the square root and plug it into the yellow or white calculators or the graphing calculators. Either one of those work. Because in parentheses, 7 squared minus 4 times 6. Well, negative 7 squared would be 49. 4 times 4 is 8, and 8 times 6 is 48, I believe. So I think this all works out to be 1. Is that what you guys got, or no, something different?
Yeah, 47. Yeah, negative.
Did you put the negative 7 in parentheses? Okay. Because 8 times 6 is negative 47? Ah, yes. Because 4 times 4 is 16, and 16 times 6 is going to give us a number way bigger. Do y'all think it's going to be possible to reduce the square root of 47 down? Because 7 squared is 49. So 47 is not likely. But we can do one thing. We can take out the I. Because we cannot leave a negative inside the square root, inside the radical. And that's it. Any other questions on 26 or 27? Page. So we're at 28 through 30. We'll look at this one, 28 through 30 tomorrow. Let's look at 31 through 33 first, because I know that we can hit it a little bit quicker, because we only got about 33 minutes left. Now C is equal to what? So create a perfect square trinomial by finding the value of C and factoring it. So for 31, well, C would equal negative 24 over 2 squared, which would be negative 12 squared, which is 144. So really, we have x squared minus 24x plus 144. Well, how would we rewrite this as a set of parentheses squared? It would be what? X. So create a perfect square trinomial by finding the value of C. What is it really asking us to find? Which is? In factor x minus 12 squared. So you can rewrite it back out as x squared minus 24x plus 144. That is fine. But I definitely am looking for the 144 and x minus 12 squared. Those are the two I'm looking for. Now, if you don't write out this, at least include this. I need C somewhere, okay? Now, if you write out just, so for this here, well, because 29 divided by 2 is 29 over 2. 4, what is, I don't have 29 squared in my head. 841, comma, x plus 29 halves squared. If you want to put it like this here, that's fine. Do we have the value of C listed for 32? Do we have it factored? That's all I'm looking for.